All right, so this is lesson 4. As a reminder before we get started, we have previously just talked about the life cycle of average or low mass stars, such as our sun, and we went into detail in a video about our sun and sort of what's going on at the core to cause the changes in its life cycle. And then in lesson 4, we're going to talk about what happens with massive stars. So what about stars with high mass? The early life is similar to average stars. There's a nebula is where these will be potentially formed. When we have the fusion occur, or clumping and gravity, we can create a protostar. Then eventually it'll turn into a yellow giant or supergiant. This is a little bit different. For average stars, this would be a yellow dwarf, but for giant and supergiant stars, it's yellow giant or yellow supergiant. Other terms you might see instead of giant or supergiant are massive or most massive. Moving on. And then instead of being a red giant, they turn into red supergiants. The progression through these phases is for the same reasons. This is the yellow giant or supergiant is because of an equilibrium between the force of nuclear fusion and the force of gravity. And then when the force of nuclear fusion is stronger than the force of gravity, they'll turn into red supergiants. Just like how for average stars turning in from a yellow dwarf to a red giant. But then they turn into supernovas. Both the giant and supergiants turn into supernovas. So when gravity can no longer hold the star together, but nuclear fusion is still very powerful, the star explodes. So most of the star's mass gets ejected into space during this explosion. So instead of, with an average star, what would happen when the gravity can no longer hold the star together and nuclear fusion is still occurring? We get the planetary nebulas where the outer layers get shed into space. So that's kind of like passive, happens. Whereas this is, it's losing its outer layers to space, but it's exploding. So much more dramatic because it's much more powerful for the higher mass stars. After that, it's going to depend on the mass. So the next stage depends on its mass, whether it is massive for giants or most massive with supergiant stars. For massive stars, gravity pulling inward is much stronger than the outward force of nuclear fusion. The star will pull in as much material as it can from the exploded remains, and now it's mostly packed of neutrons, and we call that a neutron star. So you can see the life cycle altogether down here of a massive or giant star. Nebula, protostar, yellow giant, red supergiant, supernova, neutron star. For most massive stars, or the supergiants, the force of nuclear fusion is negligible or non-existent, and the inward force of gravity is so enormous that nothing can escape its gravity, not even light. So now it is a black hole. The life cycle for supergiants, or the most massive stars, is from a nebula to a protostar, or nebula isn't really a start, but it isn't really a stage. But I like to include it because this is the only space where these are possible, right? So in a nebula, you have a protostar form, and then it will develop into a yellow supergiant, then into a red supergiant, then a supernova, and then finally a black hole. Now you have a worksheet to complete that will go over the life cycle of stars.